20,000 euros and more only for the grid connection expansion of your charging infrastructure. Can it be cheaper? Stay tuned to get more information about an alternative solution. Hello and welcome. My name is Christian Witt. I'm the product manager for the charging station management system vCharM from Vector. The operation of a charging infrastructure usually requires more energy than the building itself. In this context, the grid connection limit is the critical factor. If this is not sufficient, an obvious solution is expanding the grid connection. In this video we will take a look at the advantages and disadvantages of expanding the grid connection and the alternative solution, the load management. Let's start with the grid connection expansion. I would like to illustrate that problem on a small graphic. Let's assume we have a building with a grid connection limit of 40 kilowatts. And additionally, we know from the history that the building consumes maximum 20 kilowatts. Results in 20 kilowatts that now can be used for our charging infrastructure. Additionally, we want to build 3 charging points, and each charging point has a maximum power of 11 kilowatts. Depending on the energy supplier, a different simultaneity factor takes place. Let's assume we have the simultaneity factor of 1, so we have to calculate with the full power of our charging points. Results in 33 kilowatts that have to be reserved for our charging infrastructure. Together with the building consumption, this exceeds our grid connection limit. And now we will expand the grid connection limit from 40 kilowatt to 60 kilowatt. The advantage of the grid connection expansion is that we can use the full power of our charging points, especially if we use here the simultaneity factor of 1. The disadvantages are that you have to ask on one hand the energy supplier for permission, and on the other hand, the grid connection limit is not only a technical value, so you also have to replace hardware. Here, for example, you have to replace the connection fuses, but also the connection power cables. The higher costs here are driven by the connection and construction investments. And last but not least, the running costs, especially for commercial properties, are also increased, because you have to switch the electricity contract. It is also a fact that the demand for electricity fluctuates over the day, as you can see here in the picture. Especially in the evening, when you come home and start cooking and turning the lights on, this results then in the peak. Also, you have plugged in your car at the same time, and this exceeds then the grid connection limit. Although the available power is sufficient during the rest of the day, the grid connection limit must be expanded because of this one peak. This is where the second option comes in, the load management. It ensures that the grid connection limit will not be exceeded by spreading the energy over the day. There are 2 types of load management, the static load management and the dynamic load management. For static load management, we have a fixed power that will be distributed between the charging points. In our example, we have 20 kilowatts that is reserved for our charging infrastructure. If the first car arrives, he can charge with the full 11 kilowatts. But if another car arrives, now we have to reduce the power per charging point. So each car gets only 10 kilowatts. And if a third car arrives, you can do the math. As you can see, the actual power consumption of the building is ignored. The dynamic load management uses this potential. For dynamic load management, we measure the power consumption of the building, and depending on the power consumption, we can use more or less power for our charging points. For example, if the power consumption of the building goes up to 30 kilowatts, we can only use 10 kilowatts for our charging infrastructure. In the other direction, if the power consumption of the building goes down to 10 kilowatts, we can now use 30 kilowatts for our charging points. I often hear the concern that with load management the cars might not get fully charged. But don't worry here. In everyday life, 3 to 6 kilowatts are usually fully sufficient, especially for private charging or employee parking. There we have long idle times and typically the battery is not fully discharged. So you see, you don't have to expand your grid connection for a charging infrastructure. By using a load management system, the available power is cleverly distributed between the charging points. Therefore, the electric cars will be charged in the best possible way. With vCharM, our manufacturer-independent charging station management system, you can easily perform static and dynamic load management and save money during commissioning and operation. You can find more information on our website and please do not hesitate to contact us. Thanks for watching and goodbye. If you haven't had enough of static and dynamic load management, please take a look at our white paper. Here you will find a compact summary of the differences between the installations. And as always, please give us a like and subscribe to our channel. Thanks for watching and goodbye.